Hello everyone, welcome back to the sixth video lecture series of the linear integrated circuits. So last class we primarily discussed about the various types of applications of this. So now let us discuss much detail into the clamper circuit. So in the last class, we discussed about the clippers. So clippers are generally the circuits which are used to eliminate few portion of the input waveform and produce the output waveform. Whereas the clampers circuits are those which is opposite to that of clippers. That is, it adds some extra portion of the input to the output. So it is generally defined as an electronic circuit that produces an output which is similar to the input but with a shift with the DC level. In the other words, the output of the clamper is exact replica of the input. The peak-to-peak amplitude of the output of the clamper will always be equal to that of the input. And also, the clampers are used to introduce or to restore the DC level of input signal at the output. There are generally two types of op-amps based clampers. So one is positive clamper and the other one is negative clamper. And as the name suggests, similar to the clippers, the positive clampers are those which are used to produce or which are used to give the output which is going to be added up with the input circuit, and in the negative clamping a negative portion of the DC level is going to be added to the output voltage. So now let us move into its circuit and waveform. A positive clamper is generally a clamper circuit which is used to produce an output, and that is going to be in such a way that it gets vertically shifted by the positive DC value. So here we can see the circuit in detail. There is an input voltage V and a capacitor C is added here, and a resistance R1 is added to this negative terminal here. So now you can also see that in the positive side, there is a reference voltage which is being given here, and the resistance R2 is being connected to this reference voltage. So VEEE and VCC is also the plus and minus terminal or the biasing voltage, and a diode D is added. Here, the DC level is being given to this terminal and the reference voltage is being given to this terminal. So this DC voltage is being given at the output and which is given as the input to the cathode of the diode. While here, the anode of the diode is being compared with the reference voltage. So now the diode acts in such a way that it compares both, and at particular instant the diode turns on and one particular instant the diode turns off. So this process completely repeats, and we can see that when this diode compares both, a DC level of the capacitor voltage, that is the DC voltage, is being connected with the diode, and a level of the DC voltage is being given to the positive side. So here you can see that it has started from the sinusoidal waveform has started from 0, whereas here a DC level is being added at the 0 point, and this entire waveform is being shifted by a DC level in the positive half. Hence the name positive clamper. So now coming to the negative clamping. As the name suggests, a negative clamper is a circuit that produces an output in such a way that the input signal gets vertically shifted by a negative DC value. So comparing it with the previous circuit, you can see that the positive and the negative clipper clamper, there is only one single difference, which is nothing but the diode is being replaced in the reverse direction. So here you can see that the diode direction is interchanged, which can produce the output in such a way that a negative portion of the waveform is being added to the output value. You can see here that for an input supply, a negative portion of the DC is added. Hence, the waveform from this level is being shifted downwards. So this shows the clamping circuit, which primarily indicates that from the input signal and the output signal, a DC level is being introduced by adding a capacitance to the a capacitor value to the input side. Thank you. The remaining topics we'll discuss in the forthcoming class.